When discussing solutions quantitatively, where we're thinking about exactly how much solutes and solvents are present in a solution, the way we express this is using a concentration. So a concentration is a way of telling us how much solute do we have in a given amount of solution. And there are actually different ways of expressing this. Sometimes you can express this, how much solute do you have for a given amount of solvent. But usually in chemistry, we like to think about the amount of a whole solution. There are different concentration units we can use, but the most common one that's used in chemistry is what is called molarity. And molarity is defined as the moles of solute. So whichever solute you're thinking of, you could have more than one solute, again, present in a solution, divided by liters of solution. So this ends up being a very useful unit in chemistry because we care about moles a lot, right? That's what matters to us, is how many molecules you have for a given amount of solution. And so rather than expressing this in terms of mass, we express it in terms of moles so that we don't have to use Avogadro, don't have to use the molar masses over again to get to what we actually care about, which is moles when we're thinking about stoichiometry. And so this is the definition of molarity. Let's go ahead and look at some examples of how we might calculate this or use this. This becomes and let's talk a little bit more about what this looks like in practice. So one thing is molarity is written with the unit is just a capital M, often italicized. So you could say that you have a 2.0 molar solution that of a given solute. So let's say this is a 2 molar solution of hydrochloric acid, HCl. What that means is that we have 2.0 moles of HCl in every 1 liter of solution. And I should be specific here. It's how many moles do you have in 1 liter of your solution. So this is a fairly concentrated amount of hydrochloric acid. This is something you'd want to be very careful with because hydrochloric acid is corrosive as an acid and is a strong acid. We'll get to that idea later in the chapter. And so this is very convenient, and one way we can represent this that's shown in your textbook is we can say N to represent the number of moles and V to represent volume is another way to express this. So let's look at an example of how we can use these along with volumes to get to numbers of moles, similar to how we use molar masses and things like that. So let's stick with our 2 molar solution of hydrochloric acid and ask ourselves, well, if I had 50 milliliters of this 2.0 molar solution of HCl, how many moles do we have? How many moles of HCl? And with the molarity, this is a pretty simple question to answer. So what we know is we have a volume here in 50 milliliters, and we have a volume in the denominator here of our concentration unit of molarity. That means that if we take our 50 milliliters and multiply it by the molarity, our units will cancel out, except there's one problem. Here we have milliliters, and here we have liters. So we have to do a unit conversion first. So I'm actually going to erase what I've got here we'll put this back in a second, but first we'll convert from milliliters to liters so that our units cancel properly. And this is really common to need to do. We often measure volumes in milliliters in the lab, but molarity is defined in terms of liters. Okay, so we're going to need to use our unit conversion. We know that there is 1,000 milliliters in every liter. And now we can use our molarity, 2.0 moles of HCl per liter of solution. And we measured 50 milliliters of our solution. We say we have that much. And we can go ahead and calculate this. one nice thing here is we don't ever need to calculate the molar mass to be able to find the number of moles of HCl. I realize I didn't put that properly in the question here, but how many moles of HCl? Whereas when we're using masses, we need the molar mass to be able to get to moles. Okay, so we'll take 50 divided by 1,000. Let me just do this on a calculator so I don't mess something up. Pull my calculator over here. So we get 50 divided by 1,000 times 2, and that gives us 0.10, only 2 sig figs on this, moles of HCl in a 50 milliliter volume. And so this shows, and we can go back and forth with this. This is just one way, if we have a volume, we can find number of moles. We can also say if we measure out a certain number of moles and dissolve it in a solution, make a solution, we can find the molarity of that solution. We'll look at that in the next video.